So we're going to start talking about vertex form and square roots. So sometimes when we have a quadratic equation written in vertex form, so it's like, x minus 2 quantity squared plus 3 or something like that, we can't always find our roots because it's not in standard form. So I'm going to show you another way to do that. Now, I do want you to keep in mind that when we talk about square roots, right, a square root and a square, right, if we have, x squared, these are opposites, right? So just like in eighth grade when we stressed the solving of equations and doing the opposite operation, we will be doing that here. The other thing I want you to keep in mind is when we talk about square roots, if I have the square root of 36, we're looking for what times itself is 36. Well, 6. But I want you to think about, for algebra, right, a positive 6 times a positive 6 is 36, but also a negative 6 times a negative 6 is a positive 36. So we write this plus minus sign like this to show that it is a positive number and a negative number. So we're going to go through these steps and we're going to do a couple of we do's, and I want you to do the you do, and then you can check your you do on the PDF answer key. So we always want to make sure that we're getting that x squared by itself. And then we can take our square root and then we can reduce our square root if we need to. Do keep in mind we can write our answer with both that positive and negative, and we can check this by graphing. So our rules for solving equations will come into play. So if I need to get this x squared by itself, I need to add my 16 to the other side. So now I have x squared equals 16. So to undo a square, again, we're going to take the square root. Square root of x squared is just x, and the square root of 16 is 4. But this is where we talked about positive 4 times a positive 4 is a positive 16, but also a negative 4 times a negative 4. So you can write it like this with our plus minus symbol, or you could write x equals 4, x equals negative 4. Now we can graph this in Desmos. So what this is telling us is that these are our roots, our zeros, our x-intercepts, our solutions. That's the purpose in doing this. So if we graphed x squared minus 16, we can see in fact that the roots are negative 4 and positive 4. That's what that is telling us. I would like you to do the you do, so you can either pause the video and do it, or you can go finish the notes and then go back and do it. This one, again, we need to get the x squared by itself, so it's a positive 7, so we're going to subtract 7 just like we did in 8th grade. X squared equals 9. Take the square root to undo this squared, so x equals square root of 9 is a positive and a negative 3. And again, now if you're going to graph this one, we have to make sure everything is on the x squared side. So if you're going to graph this to check it, x squared plus 7 equals 16. Now we got to minus our 16 over here. If you're going to check it, it has to be equal to 0. Right? Where that 0 is what our y value is on our root. So now we could graph this and check it. X squared minus 9, negative 3, and positive 3. So if you're going to check it, it has to be equal to 0. Number 5 is a little tricky, right? We're multiplying by 9, so now we're going to divide by 9. So we have x squared equals, this does not simplify nicely, to 49 over 9. We're going to just leave it a fraction. To undo our squared, we're going to take the square root, and then we're going to take the square root over here. This is essentially saying take the square root of the numerator, take the square root of the denominator. And when we do that, the square root of x squared is x. The square root of 49 is 7. And the square root of 9 is 3. So plus or minus 7 over 3. And again, you can check this in the computer. If you're going to check it, you would need to move that 49 over by subtracting it. And you would look to see, in fact, if the root is positive 7/3 and negative 7/3. So let's check that. So we're going to say 9x squared minus 49. And you can see it's the green one. It is a decimal. And we had 7 over 3 was our answer. And look, 2.33. So it matches. So we did it correctly.